Welcome to Kaling Tech SRX Cluster lesson. This is an actual configuration lesson now today. But first of all, we'll start with a PowerPoint presentation. So in this lesson, we're going to utilize the two SRXNG firewalls and we're going to set them up in a cluster HA configuration. So we'll be configuring the control link, fabric ports, redundant Ethernet ports, redundancy groups, and some port monitoring for forward detection. Okay, so let's have a look at the actual topology. So I'll leave this on the screen for a couple of minutes for you, well, a few seconds anyway. So we're going to have node 0 here, we're going to have node 1 over here. These are the ports we're going to use. This is the redundant Ethernets, the redundancy groups, redundancy group 1, redundancy group 1 with redundant Ethernet 1 and redundant Ethernet 0, the fabric links, and the control link. And on the next page, we'll show you what those links are for. Okay, so let's move on and do that first. So what are the ports used for? So let's start with the control link. Okay, this is used to control the plane signal traffic. What does that mean? So it's the control plane, basically. So that's the heartbeat. That's the beat that states the chassis between the two chassis themselves. Okay. Now, what you'll find is on some actual physical boxes, there will be a dedicated HA link, and that'll be the control link. Okay, it's important to remember as well that if you put them in different data centers, etc., you must enable it so that it is like they are directly connected. And what that means is, as it goes through your switched network or your routed network, it must be on its own unique VLAN. Okay, so that it makes it seem like it is directly connected. What else does it do? It also detects threshold information. So any thresholds that you've set on there, okay, with regards to the chassis itself. It also sends that information, and configuration synchronization, written in English, so it's got an S there, so UK English. Now the configuration synchronization, what that basically means is that you do your configuration on the primary node, so node 0, and it automatically updates node 1 with that configuration, so there's no need to do both systems separately. You'll see that as we configure it anyway, because you'll see that it does a commit on both nodes. The fabric links, or fab links as they are called, what these do is they synchronize the session state objects. Session state objects, NATing, VPNs, so we get the network address translation, NATing, the application layer gateways, the ALGs, IPsec, VPNs, anything that we would classify as a session state object. And then we move on to the redundancy groups. What do they do? So redundancy group 0 is routing engine specific. Redundancy group 0 is created automatically, but you still have to configure it. Other redundancy groups are redundancy group 1 to 128. These manage the primary and failover between the routing engines themselves. Okay, it can only be primary on one node at a time. Okay, and specifies the priority of each node, and we'll go through that now. So the node that comes up first, and it has to be at least 3 seconds prior to the other node, that becomes the primary node. Okay, if both nodes come up at the same time or within 3 seconds of each other, the following happens. The node with the higher configured priority is the primary node, because we can configure it that way. But what we tend to do is, if there's a tie, what tends to happen is the node with the lowest ID, which is normally node 0, becomes the primary node. Okay, a redundant Ethernet is utilized for the transfer of traffic. It's very similar in use to aggregated Ethernet, except for one major difference. Redundant Ethernet ports are chassis failover, so it helps with the actual chassis itself, whereas aggregated Ethernet, if you remember, it doesn't matter if the chassis fails, well, it fails anyway. But the aggregated Ethernet for a port group failover, so if one of the ports within the aggregated Ethernet group fails, it still utilises the other ports. Okay, that's the major difference. So what we're going to do now is we're going to go ahead and we're going to configure up two SRX NGs for high availability and clustering. So now we're going to start the configuration work. So what I'm doing is I'm just showing you the EVE-NG topology. We've just got node 0, node 1, and we've connected all the ports, okay, so that we have everything available when we go into it. Okay, so let's go to our configuration screens. So this is our configuration screen. Now, I've not done anything with this at the moment. So as you can see with the amnesiac wording, and I've labeled them node 0, node 1. Hopefully in this lesson, you can let me know if it's not. I've got the wording very large, and hopefully you can see it okay with this background and the foreground as it is. So let's log on and let's start the configuration work. I mean, firstly, we're just going to get rid of some little bits of unwanted config when we first go onto the systems. Okay, so let's do a quick, we'll do it show config and we'll do it as a display set. Okay, so we can control C that. We'll go to edit mode and we'll delete just a couple of little bits that might cause us an issue if we don't get rid of them. So firstly, let's get rid of this. We don't need it. And let's also get rid of this license auto update. Those are the two bits we don't really need. Now, before we can do anything, as you know, we have to do a set system root authentication, plain text password, that'll do. So let's configure this. And we'll commit that and we're ready to go on that system. Let's go to node 1 and we're going to do the same on here. So we'll do a quick show configuration and we'll do it as a display set. And we're going to come out of that. We'll go into edit mode and we will delete. Don't need that. And we do not require this. Okay, and set system and we'll commit that. Okay, let's clear the screen so that we're ready for our configuration work to get a cluster up and running. Okay, right, so what's the first thing we need to do? Well, the first thing I want to show you is I want to show you our interface position currently. So if we do run show interfaces terse, we're gonna actually we'll just do GE star. Okay, so what we have is we have interfaces GE0 through to 8, and the reason we have to have this amount is because from a virtual perspective, although we don't see it, a couple of those interfaces are automatically assigned internally. Okay, so although the numbering will be the same, it won't work correctly. So what I've done is I configured up 10, which gives me 8. Okay, right, so let's also have a quick look at run show chassis cluster status. Okay, well, we don't have it at the moment, so how do we enable it? Well, to actually enable the chassis cluster is very, very simple. So what we're going to do is we're just going to enter the, sorry, by the way, before you do this, just note that to set a cluster, a chassis cluster, for high availability and failover, you will need to reboot any system that's involved in this, okay, that's going to have these commands enabled on them. So if you're working on live systems and you're going to put a live system into a cluster, take note that a reboot is required. Okay, right. So with that being said, let's get on with it. Right. My apologies there straight away. Look, we have to actually do this from what you would consider to be operational mode. Okay. So we're going to give it cluster ID. So this is the ID for the whole cluster. Anything that's in this cluster will have this ID of 1. The next part is this particular node that I'm on. What do we want to call it? What number do we want to give it? Well, we're going to give it 0. It's labeled 0 up here as well. Look, at the top. So we're going to give it 0, and we're going to give it the automatic reboot. Okay, so there we go. And we're going to do the same on node 1. So we have to go back to operational mode. We're going to do set chassis cluster. Cluster ID is going to be, like I said, 1. But this is going to be node 1. And reboot. So this, because it's virtual systems, it takes about 10 to 15 minutes for these to reboot. So I'll continue with the lesson once that has completed. Okay, so now the systems are back up and running. So let's have a look. Let's log on and let's have a look and see what we have. Okay, so we're going to go to the CLI. And we are also going to go to node 1 and log in. Okay, so the first thing you'll notice straight away is now we have this. Okay, we have secondary node 1 above the command prompt. And in node 0, we have primary node 0. So the way we can look and see if the actual cluster is there at the moment, the basics of it, it's not going to do much at the moment, but it is there, is we can do a show chassis cluster status. Okay, and there we go. So we have it up and running. Now, one of the issues we've got here, and we'll deal with this once we start getting onto the redundancy groups, because that helps then at that point. We've only got redundancy group 0, which, if you remember what we said, is the control plane side of things for the routing engines. Okay, so at the moment, their priority is 1 and 1. Okay, so it's going to be a tie. What we don't want is we don't want that, because what could happen is at some point node 1 could become primary without a failover occurring, and we don't want that to happen. Okay, so what we're going to do is, as we go through the configuration, we're going to give priorities. Okay, so the second step that we want to do now, and by the way, all configuration, as you'll notice when we do a commit, I'll show you when we commit, all configuration will now be done only on node 0 or the primary node as it may be at that point in time. Okay, which currently at the moment is node 0 for us, and we want that to be like that all the time. So what we're going to do next then is we're going to configure up the fabric ports. Okay, remember those are used to pass the real-time objects, you know, like application layer gateways, IPsec tunnels, VPN tunnels, NATing, that kind of stuff. Now, from the perspective of an actual physical box, okay, when you're on a physical box, if you've got more than one ASIC in there, it's better to have the interfaces as far away from each other as possible so that you have full, complete redundancy. Because if they're both connected to the same ASIC and that ASIC goes down, but the box itself doesn't go down, then you've lost it anyway. Whereas if you have one physical port in in one ASIC and one physical port in another, if one ASIC goes down, you've still got the other port to utilize. Okay. What we're going to do here though is just configure up a couple of ports. Okay. What you will also notice as well that I need to show you is, and it's not necessarily going to be the number 7 either, because we do everything from node 0 and it sees it as node 0. How do you know what port you're looking at if you type in, for example, show interfaces G000? You don't, because it kind of utilizes both the same way. So you don't know if you're looking at the primary or the secondary. Okay, so a way that we can look at that and confirm that, okay, is if we do a show interfaces terse and we just look at the GE ports. Again, remember we only had 0 to 8 before. Okay, so what have we got this time? Okay, so we've got 0 through to 8, but now we've got these 7s, look. Now what they indicate is they indicate the secondary node. Okay, it might not be a 7 on your system, it might be a 3, it might be a 5, it could be a 9, who knows? It just depends on what Juniper's decision is at that point in time with regards to that software. But if we want to definitely know that we are looking at the secondary node interface, we must do this one. Okay, not G000. And that's the same when we do the configuration work. You'll see that in a minute. We have to utilize this 7 interfaces for the secondary node, okay, because it'll only see the first node. It sees G000 as the same node, primary. It doesn't matter that it's on the secondary. Okay, so let's go ahead and set up those fabric ports. Okay, so we're going to go into edit mode and we're going to do set interfaces fab. This is fab 0 initially, and the fabric options, and we need the member interfaces. These are now the physical interfaces that are going to be linked to these fabric ports, and we're going to use 002. And if we use the up arrow, it's still fab 0. We're going to use 003. Okay, and then we're going to do set interfaces fab 1. Now, what this means is fab 0 is node 0, fab 1 is node 1. So as I've just said to you, what interfaces do we have to use on there? Well, we're going to use the same interfaces because they're the ones that are connected, but we can't use 002 and 003. So what we've got to do is 702 is the equivalent on fab 1 physically as G002. Okay, and you'll notice that on the topology I gave you. And 703. Okay, that's those interfaces configured. Next, we are going to move on to how we can configure and set the host names and everything from the one system. Before we continue with the rest of the configuration, this needs to be done as well. Okay, so we're going to do that now. We can do that with a special command called $node that's in parentheses. Okay, and I'll show you how that works. So we're going to do a set groups. And you can do this with any command you want to do. You can use this. I'm just using 2 particular commands. You'll notice at the moment we don't have a host name. Look, we just have root in here. Yeah, see that? Root. So, set groups node 0. So that's this node. What do we want to do on this node? Well, we want to set system host name, and we're going to call it node 0. Okay, that's what we're going to call it. We're also going to do set groups node 0 interface, because we'll want to configure up the FXP0 unit 0 interface. Okay, so we're going to give it a family inet address, and we're just going to give it 192.168.1.1/24, I guess. That'll be the first one. Then we can do set groups node 1. So this is what will be applied to the other node, and we're going to do system hostname, and we're going to call it node 1. Okay, and we're also going to do set groups node 1. Node 1, and we're going to do the interface fxp0.0 family inet address, and we'll give this one 192.168.1.2/24. Okay, and then this is the command that applies everything. So we do a set apply groups, because those are the groups, look, node 1 and node 0. So we're going to apply groups, and we need to use our special $ open parentheses node close parentheses command. Okay, and then we're going to commit that. And when we do the commit, you'll see now that it commits it across both nodes. Okay, if you have a look at what's going on down here for the commit. Okay, so you see it's committed across the nodes. All right, so you notice as well now we have root at node 0. All right, and if we were to go to node 1 and do an enter, we now have root at node 1. And if on here we were to do show interfaces terse fxp and star that, there you go, there's your IP address that we've just assigned without even having to go onto this box. Okay, right, so let's continue now. So if you're using bare metal boxes or anything like that, and you want to connect to FXP0, the management interface, you can now, of course. Okay, so what we're going to move on to next is we're going to move on to configuring redundancy groups and the redundant Ethernet interfaces within those groups, okay, which are obviously virtual interfaces as well. So we are going to configure up the redundancy groups and the redundant Ethernet interfaces. So let's try and remember that the control plane uses redundancy group 1, and the data plane uses redundancy group 1 and above, up to 128. Okay, so we're going to start by configuring redundancy group 0 and assigning it a priority. As we noted before, currently the priorities are set to 1 on both, and we don't want that because we want node 0 to always be primary unless a failover occurs. In this case, just so that you're aware, the higher the priority number, the greater the priority. Okay, so let's go ahead and do that. So we're going to do set chassis cluster, and we're going to do a redundancy group 0 first, as we've just said, node 0, and we're going to give it a priority. Zero priority, and we're going to give it 200. Okay, this is normal. And then what we're going to do is we're going to do set chassis cluster redundancy group 0 node 1 priority is going to be 100. Remember what I said, the higher the priority, the better. Okay, so we're going to commit that. And what we're going to do is once that's committed, as it has been, we'll do a run show chassis cluster status. And if you notice now, we have changed the 1 to be 200 and 100, which is exactly what we want. Okay, so that's redundancy group 0 configured. All right. Now, before we can go ahead and start doing redundancy group 1 and the redundant Ethernet ports, we have to do what is very similar that we have to do with the aggregated Ethernets. We have to tell the Juniper system how many ports we're actually going to use. For redundancy group 0, it doesn't require this, but when you add in more redundancy groups, it does. Okay, so what we're going to do is we're going to do a set chassis cluster, and we're going to do a redundant Ethernet count, and we're going to give it 5. So we're going to say, yeah, okay, we'll use 5 ports. It doesn't have to be exact. It can be above what you're going to use, but it can't be below it. Okay, so there we go. We're going to set that, and we'll commit that. So now what we're going to do is we're going to create redundancy group 1, and we also have to do the priorities on this exactly the same. Okay, so let's do a set chassis cluster redundancy group 1, and we're going to give node 0 a priority of 200, and we're going to give node 1 a priority of 100. Okay, and we're going to commit that. Okay, so that's committed, and what we can do now is we can go again. We can do run show chassis cluster status. Okay, so now we have redundancy group 1. Now, currently at the moment, it does take a couple of minutes for it to recognize that it's included in this. So at the moment, we're seeing it as hold, but what will happen is, as you can see, they're starting to come up, and there we go. We've got the primary and secondary configured there as well now. Okay, so that's our redundancy groups set. Now what we have to do is we have to now configure and set up our, sorry about that. We now have to set up and configure our physical interfaces for the redundant Ethernets and put them within the redundant parents. Okay, so the redundant groups, if you like, because otherwise how's the failover going to occur? All we've done at the moment is basically created the groups and given them a priority. Okay, so let's go ahead and do that. So we're going to set interfaces GE004. Okay, and we need to put the gig ether options, and we're going to say redundant parent, and the redundant parent is going to be reth0. So we're creating a redundant Ethernet, which is a virtual port, almost like an aggregated Ethernet, but because we're linking it to a redundant group, rather than aggregated Ethernet, which is port only for failover, okay, a redundant Ethernet is chassis and port failover, okay, and this is what's required within the cluster itself. Okay, so there's the first one done. Now what we're going to do is, obviously we have to do the other end. And again, remember, it's not GE004, it's going to be GE704. Okay, so it's the equivalent. The actual physical interface at the other end is GE004, but from a cluster perspective, it sees it as 704. Okay, and again, the gig ether options, the redundant parent, and the redundant parent is reth0. Okay, now what we can do is we can treat reth0 like we would an aggregated Ethernet or any other port, if you like. So what we're going to do next is we are going to now give reth0 unit 0 family inet address, and let's give it 10.1.1.1/24. Okay, so we've given it an address now, and lastly what we need to do is assign the redundant Ethernet interface to the redundancy group, and we're going to assign it to redundancy group 1. Okay, so we're going to do set interfaces reth0, redundant ether options, and redundancy group 1. Okay, now what we're going to do is we're going to do the exact same procedure, but we need to create redundant Ethernet 1. Okay, so we set interfaces GE-006, The gig ether options, and the redundant parent is going to be reth1. And we're going to set interfaces. We've got to do the equivalent the other side. Interfaces G-706. And the gig ether options for the redundant parent, reth1. Okay, and then we're going to do set interfaces reth1 unit 0 family inet address, and we'll give this one 10.1.2.1/24, and then we need to set that into our redundant group reth1, and we're going to do the redundant ether options, redundancy group 1. Okay, and we're going to commit all of that. So again, let's have a look at our run show chassis cluster status to start with. So that's fine. We can still see that. That's all good. Now we're going to do run show chassis cluster, and we want to look at the interfaces now. Okay, so let's have a look at our interfaces. So let's just scroll up a little bit so that we've got all the information. So the control link status is up. It's assigned EM0. That's because it's a virtual system. The chances are you might find that that's the control link itself is probably a dedicated port on some SRX systems. There'll be a dedicated HA port, and that'll be for the control link. Okay, so the fabric links are up, the status is up. There's our fab ports, they're all up. Okay, and there's our redundant Ethernets, and they're up as well. Okay, and our pseudo interface, okay, is loopback 0, and that status is up, and that'll always be up anyway, and that's because of the routing engine side of things, and that's why that's redundant group 0. Okay, so that's our interfaces set. Now, what we need to make sure of now, though, is rather than it just failing completely and then failing over, because that is a system configured, if you like, for failover. But what we want to do is we need to do forward monitoring checking. All right, we want it dynamic as well from an interface perspective too. Now, what we can do is we can use something called interface monitoring, and what that does is it tracks the interface status and forces redundancy group failover to the other node if the total weight becomes 0. So we give it a weight of 255 initially. So 255 minus the configured weight would be 0. Okay, so the total weight becomes 0. For immediate failover, for the single interfaces to fail status, monitor weight should be set to 255. If you only want the failover to only occur if 2 interfaces fail rather than 1, then you can configure the weight to be 150 on each interface. So what that means is basically if 150 was to be minus from 255, you'd be left with 105 still, so it still wouldn't fail over. But if both interfaces went down, you'd have a 300 off of 255, which gives you a minus figure, which means it will then fail over. So you can monitor all of those interfaces, okay, all of them. But all we're going to do at the moment is I'm just going to monitor GE004, and I'm going to disable it and show you what happens. Okay, all right. So firstly, let's set a monitor for that particular interface. So let's do set chassis cluster, a redundancy group 1 interface monitor, and we're going to monitor 004, and we want to give it a weight of 255. Okay, so let's commit that. And let's have a look at our run show chassis cluster interfaces. Okay, so we'll note down here that now we're monitoring G004. Its weight is 255 and it's in an up position. Okay, so what happens? Let's do a run show chassis cluster status. So as you can see, we've got node 0 in both redundancy groups are in a primary position. So let's go ahead and disable GE004. Okay, so set interfaces GE-004 and we're going to disable it. Okay, so we're going to simulate a failure on that interface. So let's commit that. And let's see how quick this works. Okay, so we're going to do a run, show chassis cluster status. Straight away, node 0 has gone to, well, it's down basically, and it's become secondary. Okay, so let's do a run, show chassis cluster interfaces. Okay, so we see all of these up as they should be. Okay, however, as the monitoring shows us, G004 is now in a down position. Okay, so the question is now is how do we get that back up again? Okay, because we're doing a simulation at the moment, and we've got to remember that we want node 0 to be the primary, and currently at the moment, if we go back to our redundancy group 1, node 0 is now the secondary. So let's see what happens if I do a delete interfaces GE-004 disable. Okay, and we'll commit that. And if we do a show run show interfaces terse GE-004, it's up, and it's part of an aggregated Ethernet but redundant Ethernet 0, 0. Okay, so it's up, it's up. Run show chassis cluster status. However, although we've got it back up and it's got a higher priority, it's still in a secondary position. And the reason for that is because we have no preempt to state, well, I always want to be and make sure that I am the primary node. As I said, if you have this 3-second rule, okay, and it doesn't hear the heartbeat, it switches back over. But of course, that heartbeat is always going to be there. So the only other way you're going to get, other than the preempt, the only other way you're going to get that back to a primary is by failing over again from the current primary on that particular system. But in a live environment, you're not going to want to do that. So the way we can get around that is we can set a preempt, and what that does is it says, look, I'm the primary and I always want to remain the primary. So let's do a set chassis, and we're going to call it cluster redundancy group 1 preempt. Let's commit that. Oh, let's commit that. Okay, and let's do a run show chassis cluster status. And there we go, we're back to primary again. Okay, and that's because of the preempt rule that we've put in place. Okay, so I'm showing you the different ways that you can monitor these systems. This is a basic cluster formation for you. It's up, it's running, and it fails over correctly. Hope you've enjoyed this lesson, and if you've got any questions for me, please just let me know. Thank you.